Ladies and gentlemen, welcome to the fifth event in the series of webinars hosted by Greengrow's Knowledge Partnership, GGKP. Taking this opportunity, let me extend my deep gratitude for registering and joining. My name is Anastasia Buchok, and I'm working for GGKP Global NIP Update Project. And today's webinar is Sectoral Approach to Inventories of POPs and Other Chemicals of Concern in Buildings, Construction, Electrical and Electronic Equipment, and Vehicles will introduce a new approach to inventories of industrial POPs in such sectors as construction, electronics, and transport. And the webinar will also present the sectoral guidance for inventories of POPs and other chemicals of concern in these three sectors. And we therefore sincerely hope that this information will be helpful for you and for your NIP review and update. Finally, our today's webinar will be conducted in English language and would be recorded. This event is supported by 6 my colleagues who would ensure interpretation into French, Spanish, and Russian languages. Please feel free to select your language in the bottom panel of your screen. And the event would be technically facilitated by my GGKP colleague, Sumin, and me. Once we start, please feel free to introduce yourself in the chat. It's a great opportunity to meet colleagues from all over the world. And now let me introduce our today's speaker, Mr. Roland Weber, who has been researching POPs for decades, supported a number of countries in development of their NIPs. Roland will introduce us to the new approach to POPs inventories and the sectoral guidance he authored on the POPs inventories. The floor is yours, Roland. Thank you.
Yeah, thank you, Anastasia, for the kind introduction. Yes, so today we have the presentation on and the introduction to the sectoral approach to inventories of POPs and other chemicals of concern in construction, electronics, and vehicles. The guidance I have also developed for UNEP. And the presentation and the webinar will be in 4 parts. Part A is on basics on industrial POP inventories and coordinated POP inventories in these major sectors, and option for considering further chemicals of concern relevant to other multilateral environmental agreements. In part B, we will look to the assessment and inventory of POPs and other chemicals of concern and electrical and electronic equipment and related waste. Part C will then be on the transport sector and related waste, end-of-life vehicles, and part D then on construction and buildings and the related construction and demolition waste. First to the POP inventory. So a POP inventory compiles information of the country on past and present production and current use, stocks and waste of chemicals listed under the Stockholm Convention. As many POPs are used in the manufacturing of products and articles which may have a long service life, a comprehensive inventory should also estimate the amount of POPs in the products and articles in the country, for example, in buildings, in electronics, or in vehicles, along the whole life cycles, thus contributing to the provision of Article 6 of the Convention on managing of waste. The main objective of developing inventory is to understand the quantity of POPs and POPs containing waste in the country, to acquire information to appropriately regulate and manage POPs and the POPs waste, and to update the national implementation plan. So that's also the part of our project here is for the major update of NIPs in more than 30 countries and the related action plans for POP management and destruction to comply with the requirement of the Stockholm Convention, including Article 7 on NIPs, Article 15 on reporting, and Article 6 on waste. Objectives are further described in the general guidance on POP inventories you can find here on the Stockholm Convention website. On the Stockholm Convention website, you can also find all these guidance documents, and we have here a range of inventory guidance documents for the individual POPs. And for the new NIP update, UNEP was interested in a sectoral approach of the NIP update, and therefore I have developed here the guidance for UNEP on the sectoral guidance on these three sectors of today: electronics, transport, and buildings. In addition, we have developed two more guidances. One guidance on how to, let's say, manage POPs data and generate POPs data in the country, and on quality assurance and quality control guidance. And these webinars will come then in October. Inventories often compile information on individual POPs following the inventory guidance documents I just showed. However, it is wise that a POP inventory team, when gathering information on POPs in a specific sector, best gather all the information on all POPs and which are relevant for the respective sector. Also, for the final management of waste of a sector, information on all potentially related POPs should be available. And the objective of the sectoral guidance document is to facilitate here this sectoral assessment for POP inventories, and that information gathering of POP inventories is better coordinated. So this sectoral approach should then ensure that stakeholders in different sectors or ministries are approached only from one inventory team, for example, for gathering the POP data, which can save time and money for the stakeholders, but also it can save time and money for the inventory teams. Yeah. So here is an overview on the different major POPs in the three sectors we are talking about. Yeah, I mean building sector, electrical and electronic equipments, and the transport sector. Yeah, and so that's one of the tables from the sectoral guidance where you see all relevant POPs are listed here. Then you can see for the different sectors, for which sectors they are have major relevance. For example, here for DKBDE, in all the three sectors, DKBDE has major relevance. Or when you, for example, go to PCBs, you see that, yes, they have been majorly used in buildings and construction. Here in open uses, in sealants and paints, we will hear to it. Of course, also in electronics with all the capacitors, but also a little bit in the transport sector. Also, we will hear for it later, because also you have some capacitors there. Yeah, and so here with this table, you get a first overview on the different uses, the major uses and minor uses, and also it's compiled for which year and decade these POPs have been used, because that's relevant to know if buildings from build 1920, yeah, they do not have PCBs, because PCBs have only been used here from 1930s to 1980s. And I have introduced this review on the production of POPs from Lee et al. From 2023, where they have compiled for the POPs until 2019 the complete production over the decades. And here today I just want to show here the major POPs. For example, here the DKBDE, which has had a productions of 1.6 million tons. The total PBDEs had a production in total of 1.9 million tons, therefore very relevant. But you see here, for example, the major production also was here in the 1990s and the first 10 years in 2000s, with a decrease then in the last 10 years. Also, a major POP is hexabromocyclododecan. In total, 700,000 tons have been used, 19% in EPS and XPS, with about 1.5% in EPS and XPS. We have about 42 million tons of EPS, XPS, still largely present in insulation foam. And what you see here, the major use have been in the last 20-25 years. So therefore, this stock is still with us. Also PCBs, had been big production, more than 1.3 million tons have been produced, but the major production here was in the 1960s and 1970s. And already in 1980s, there was a strong decrease and hardly any production after 1980s. Yeah, but still, as you know, equipment, for example, transformers with long service life, they are still with us, and there is still a big work on management of the remaining PCBs, which need to be finished by 2028. A last big pop is short-chain chlorinated paraffins. So this is overall the pop which have been produced in the largest volume, 9 million tons, and still the production is ongoing in the 100,000 tons production per year. And then we have the pop candidate medium chain chlorinated paraffins, which today might have close to 1 million tons production per year, and therefore are also very relevant, and major uses are in these three sectors. But POPs are only one important category of chemicals of concern in these sectors. Other relevant chemicals of concern are addressed, for example, by other multilateral environmental agreements like Basel and Rotterdam Convention, Minamata Convention, Montreal Protocol, and the United Nations Framework on Climate Convention on Climate Change. Moreover, a range of chemicals of concern have been flagged under the strategic approach to international chemical management, SICHAM, as emerging policy issue. For example, hazardous substances within the life cycle of electrical and electronic products, lead in paint, and endocrine disrupting chemicals. Or other issues of concern like per and polyfluorinated substances. So when POP inventories are developed, gathering information on other chemicals of concern can be taken as an option, considering the synergy approach of other MIAs related to chemicals and waste, and aiming for an integrated management of POPs and other chemicals of concern where appropriate. Also, here the global framework on chemicals, which is the successor of SICHAM, highlight here that it's important to look to sectors and do a sound management of chemicals throughout the life cycle. This global framework also highlights that actions by individual sectors and stakeholders, including a collaboration among key sectors and stakeholder groups, are important. And also they highlight that the involvement of industry and the private sector throughout the value chain need to be significantly enhanced under the framework at all levels. Yeah. And of course, POPs are also related to this global framework on chemicals. Also, they have their own convention, but it is then a good cross-cutting. And I would like here to add, especially to industry and private sector, that it's important to have this extended producer responsibility as one guiding principle in the involvement. And especially for electronics, for end-of-life vehicles, there is already extended producer responsibility examples from different countries. And UNEP has capacity building on the website on extended producer responsibility, and from the OECD also some considerations on buildings. So when we look to the new listed industrial POPs like PFOS, PFOA, DKBDE still produced, short chain and medium chain chlorinated paraffins still produced, UV328, Decloran Plus. The inventory approach aims to consider also the whole life cycle, yeah, like highlighted from the Convention on Chemical Management. So here we look from the production, including imports, the use in production, end of life, and more important, also recycling, considering that we need to go to a more circular economy, to the life cycle of POPs. And this is also the way how we develop inventories. So considering that waste, and including the plastic crisis, and most of the POPs today, as I will highlight during the presentation, are plastic additives. So therefore, considering the waste and plastic crisis, and the limit of resources. We need to move to a more circular economy. This is stressed by different UN organizations, also by GEF and, for example, the European Union. But when we move now to a more circular economy, we need to take care of the fate of hazardous chemicals and materials in recycling. So therefore, POPs and other hazardous chemicals need to be controlled in a circular economy and phased out as good as possible, best within a global approach like the Stockholm Convention. A major share of these POPs have been used in plastics, including in electronics, and here you see the total global production of plastics and the different major sectors of plastic production. Yeah, it's from Geyer et al. And you see here that the transport, the electronics, and the building and construction sector are huge sectors of the plastic use globally. So in total, these three sectors make around 30% of plastic production, which is used in these three sectors. And considering the long service life here, for example, for plastic in buildings, but also plastic here in the transport sector, it is likely that today more than 50% of all plastic stocks are contained in these sectors today and are highly relevant for plastic management and recycling today and in future. So therefore, a very strong link between POPs, plastic, and recycling. And when we also include the textile sector is the third largest sector of plastic production, especially around 60% of all the textiles are polyesters. Yeah, and polyester is a plastic. Yeah, it's at the same time PET and polyester is the same chemical. Yeah, and also textile partly contain POPs. Yeah, so therefore also this sector belongs to POPs and plastic sector. But in today's webinar, I will concentrate on the first three sectors and will not tell much on the textile sector. Inventory and management of POPs in major affected plastic use sectors can improve the management also of the plastic in these sectors and result in the pollution of these sectors. So we have already good experience with the global phase out, for example, of hexabromocyclododecan, which has been used mainly in construction, but also in textiles and in electronics and partly in transport, as you will see. And also the stop of nearly all DKBDE production. So only, for example, India is today producing some DKBDE. Yeah, so already here we have, because of the Stockholm Convention, a depollution partly of the plastic sector. Stockholm Convention parties also started to inventorize and manage POP in these sectors together with the plastic since 2011. PBDEs, for example, were listed in 2009, and then countries have started inventories after 2011. And with the further listing of plastic additives like short-chain paraffins, Decloran Plus, UV328, or medium-chain chlorinated paraffins, which is proposed for listing in 2025, this kind of link and management of plastics and POPs will further extend. POP inventory and management can become here a good synergy with the upcoming plastic treaty. So the POPs management in these sectors require the management of plastics. Yeah. So actually, egg and hen. Yeah. So we need to manage these plastics, and only by then we can manage the POPs. We cannot manage the POPs if we don't manage the plastics in this sector. But at the moment, we have the Stockholm Convention. Therefore, since more than 10 years, we are using POPs and have started to inventorize and manage these sectors. But what needs to be highlighted is that only a share of plastics in these major sectors contain POP additives. In below figure, the use distribution of major polymers in Europe in the major use sectors are compiled. So here you see packaging, building, automotive, electronics, agriculture, household, others. And the use frequency of the POPs is often unknown. Yeah, but what we know, for example, that the use frequency of POPs in EPS, XPS in the building sector have been high. Yeah, so here when you look building and construction, here the polystyrene, you see, yes, a big part of these polystyrene in buildings contain POPs. Yeah, but now it's substituted. So since a few years, it does not contain POPs. But until, let's say, 2017, more or less all EPS, XPS contained, if there was the flammability standard, contained POPs. Yeah, but often it is not known what is the frequency of contamination. For example, here when we go to polypropylene in buildings, I'm really not sure. So I just have put here a small part as impacted, but here more monitoring is needed to understand what is the share of the different plastics in the different uses in respect to impact. For the development of inventories for industrial POPs, we have developed around 2010 for these guidance documents of industrial POPs, a strategy to develop the POPs with 5 steps. So this is step 1 is planning the inventory, including establishing national inventory teams, identify the stakeholders, define the scope, develop work plans, then to decide what is the collection methodology, which we proposed in a tiered approach. I will come to it. And then collection and compiling the data from the different sectors, managing and evaluating the data, and possibly when seeing that the data are not good enough, going back to step 1 or 2 for this area and do again inventory. And finally, compile this data with an inventory report. And here for step 2, we have developed for these industrial POPs a tiered approach, because UNEP and the BRS Secretariat wants that all countries can do at least a sort of inventory, even if it's only with a special situation, no time, no money, difficulties in the countries, only an initial assessment. This means to do only a desk study and some consultation with stakeholders and get an overview, yeah, for the management then. Yeah, so normally we hope that at least countries can do a tier 2 inventory, a preliminary inventory with detailed data collection, detailed statistics, interviews of stakeholders, maybe site visits, and do a semi-quantification. And for this quantification in the guidance documents, we have tried to develop impact factor of certain, for example, products in electronics, the PBDEs, that countries are able to develop a semi-quantification. And but it's also encouraged, if possible, to do a tier 3 inventory with additional measurements, but often countries, developing countries, do not have the measurement capacity. So therefore, it's satisfying to have a tier 2 inventory, which is robust. Also, a robust action plan can be developed on a robust tier 2 inventory. And what we have done for the sectoral guidance, we have for the sectoral guidance for all three sectors developed case studies, inventory case studies. Here, this is the example of the inventory case study for POPs in the transport sector in Nigeria. And you see here, that's the table of content of that case study. So here we have described the different steps: planning of the inventory, choosing the inventory methodology, and then collecting and compiling the data. And under collecting and compiling the data, we have done a tier 1 preliminary assessment, a tier 2 inventory with the assessment of the different uses in the country. And we have also a part, a tier 3 inventory, where, for example, in Nigeria, we have analyzed some of the plastic materials. And for the country, we have developed material and substance flow analysis. which in the inventory guidance is recommended as one tier 3 approach, because it gives really a very good overview. And if a dynamic substance and material flow analysis is developed, even you can predict in the next 10, 20 years what might be the amount of waste containing POPs coming into end of life. Yeah, so this is, they are accessible. They are also on the green policy platform, like the sectoral guidance. So you can download and you can have a look to that. Now, Anastasia, we come to Paul on the relevance of industrial POPs in the sectors. Maybe you can put in the...
Sure. Just a second. We're launching the poll. And I hope you can see it. Can you see it, Roland?
Yes, yes, see it.
Okay.
So it is, what sectors of uses of industrial POPs do you consider most relevant? Electrical and electronic equipments, the transport sector, the building and construction sector, or textiles, or all of the above? Okay, yes, come in. We already have 40, 50 answers. And here you see most of the answers. We wait maybe 10 seconds more, because now we have 70. Okay, so yes, so what we see with the answers that we have here most answers for all of the above. Yeah, that POPs are relevant for all sectors. I agree with this. Yeah. And then we have also some answers about that most POPs are in electrical and electronic equipment. Yes, for brominated flame retardants, which you have addressed, the DKBDE, or for example, the octa-BDE especially, the largest part was of octa-BDE in electrical and electronic equipment. But when we, for example, look to chlorinated paraffins, they are mainly in buildings and construction, as we will see. So there were also 10 answers from 79, which said that buildings and constructions are the most relevant for POPs. Yeah, and that's also partly true. We have only 4 out of 79 for transport and 3 out of 79 for textiles. POPs are also used in transport and textiles. And for the transport, you will see that the POP levels are in average lower, but also relevant, as you will see. And for the textiles, yes, overall the use is less, but there are POPs used, for example, the PFAS, which are also relevant, and which are also relevant in respect to exposure, for example. Okay, so we can stop that poll. And then we come to the different main sectors, to the individual sectors. So major sectors for collecting data for industrial POP inventories. This is at the same time also step 3. So the 3 sectors, electronics, transports, and buildings, construction, contain the major share of industrial POPs and other chemicals of concern, but are at the same time also large resource for recycling, including metals and plastics and others. Therefore, it is, in our opinion, useful to have an overall inventory, not only of POPs, but also of other chemicals of concern in these sectors, also inventory of plastics, and also of resources, as a basis for developing management strategy for these 3 large waste and resource sectors. Yeah, and the first part, I start with the electronics. So e-waste is one of the fastest increasing waste category in the world. In 1992, there was 14 million tons. 10 years later, 24 million tons. 2022, we already had 62 million tons of e-waste per year. And it is predicted that by 2030, we have about 74 million tons of e-waste every year. Yeah, so we already discover challenges of developing countries, but also industrial countries of the management of this waste. And this will increase in future. And plastic is a part of it. So in average, what you see here, the plastic has around 20% of the total weight of e-waste. Yeah, there are different sectors. So some have a higher share of plastics, like small household appliances. And for example, lighting equipment has a very small share, only 3% of plastic, but the average is around 20% of plastics. So this means when we look to the 62 million tons of electronic waste in 2022, they contained around 12.4 million tons of V-plastic, and this is generated every year and is increasing. And if inefficient and poorly sorted e-waste plastic, we know, result in the contamination of plastic recyclates with POPs and other hazardous substances, which result then finally in POPs contaminated new products. Here, for example, you see for children toys, there are many publications. I recommend you to look, for example, to the study of Kashiwara or from 2020, or from Chen, that was the first study in 2009, who found that basically all plastic toys in China had some impact of brominated flame retardants. And also kitchen tools are impacted. So this is Professor Miriam Diamond from Toronto University. She analyzed her salad servers, and she found about 1,000 ppm of PBDEs in her salad servers. This is a study from Czech Republic where they analyzed coffee cups, and here is this black coffee cup lid. And also here in these coffee cups, some of them were 1,000 ppm of PBDEs. And from there, you can have a direct exposure. So this shows that the recycling flow of PBDE and brominated flame retardant containing plastics seems largely uncontrolled, and that we need a better life cycle management and a better control. So the inventory can be here a basis for a better management, and the recycling sector needs considerable improvement and BAD-BEP for separating of problematic materials. The Stockholm Convention BAD-BEP guidance has dedicated sections explaining this kind of separations. And what is very important, this kind of recycled plastic should not go back into sensitive uses, because even if you have a good separation, still some brominated flame retardants remain, including PBDEs, and we do not want to have them finally in toys. Yeah, but if there is a minor, let's say, concentration of PBDEs in a television, which is less than 1,000 times you had before 20 years ago, that is no harm when you do a risk assessment. So therefore, the separation and the recycling of e-waste plastic, but also end-of-life vehicles plastic, is very useful. Yeah, so you have a growing amount of supply. Today, there are good technologies for separation. In total, the new plastic is using only around 10% of the energy and around 10% of the water consumption, and can save per ton produced of plastic around 1 ton or even more. So if then these go back to the same sectors, it is, in my opinion, very reasonable and appropriate. So when you have such a recycling, I know from a number that around 60% of the incoming e-waste plastic can afterwards be recycled, and 40% of the plastic with high PBDE, HBCD, other brominated flame retardant, this can then be destroyed and thermally recovered. An inventory of POP and plastic in these sectors can contribute to the environmentally sound management and a safer circular economy for plastic, which is an aim not only of the Stockholm Convention, but also of the Plastic Treaty, which is currently under development. So in the sectoral guidance for all the sectors, I have developed overview tables for the different sectors, and that's here the example for the electronic sector, on the different POPs which are included in the electronic sector, the major application here of the different POPs in the respective sector, the time of use, then the relevance for the life cycle, and potential sources where more information can be found. But the sectoral guidance itself is a quite good source, and then also linked to the different inventory guidance. And I have done a tentatively prioritization of the different POPs in the different sectors. We are happy about the comments. That's now the first version. Yeah. And if you consider, for example, that you think one of these priorities is not appropriate, you can write to GGKP, to the Secretariat, or to me. And if we will do an update of the guidance, we also might do some additions. So the inventory of POPs in plastics in electronics is expected to address the following areas. The first is, with the e-waste plastic, we aim for a total amount of plastic in electronics and electronic waste. And there then the amount of POPs in the share of impacted plastics. So for POPs currently produced, also the use in new electronics and electronic equipment is needed. And also the imported electronic need to be controlled. But like I said, there's hardly any of the new POPs produced, which is still used at high levels in the electronics. So this is has a lower relevance. Then POPs in second-hand electronics imported, POPs in electronics in the stocks, stored in households, public and private sectors, and then very important, the POPs in waste streams, in e-waste plastic and their management, including the plastics which are used for recycling, the total amount of POPs which go to landfills. So this kind of information can contribute to an overall plastic inventory as a basis for an environmental sound management of plastic waste, considering POPs, and if you include also other chemicals of concern, also these other chemicals of concern. For the inventory of the PBDEs, we had sufficient data to really specifically propose different impact factors for different type of electronics. Yeah. So here you see the different relevant electronics electronic categories. And here you see the average amount of the POPs, the PBDEs listed in 2009, hexa and hepta BDE, and here you see the concentration of deca BDE in the plastics. Yeah, and for example, here you see with the PBDEs listed 2009, they were especially relevant for the cathode ray tubes. Yeah, in computers and in televisions. Yeah, while when we go to deca BDE with a much higher use, they are relevant in more sectors, and they are also present at considerable higher concentration compared to the PBDEs listed in 2009. And here one interesting example are, for example, the flat screen televisions, where for the PBDEs listed in 2009, we have hardly any PBDEs in average plastics in flat screens, because yes, they were produced mainly from 2006 on the flat screens, and the Octa BDE production stopped in 2004. Yeah, so therefore it's understandable. We do not find really the Octa BDE, hepta and hepta, hexa and hepta BDE there, but there's a deca BDE which is still produced and also impact here the flat screens. And this value you need to compare then to the low POP content here from the Basel Convention. And here we have at the moment 3 provisional low POP content proposed: 1000 for PBDEs, 1000 milligram, 500 milligram, and 50 milligram per kilogram. And you see here this is raw and average. Yeah, so you see that basically most of these products are above the 50 milligram per kilogram, and some of the sectors are even higher than 1000 milligram per kilogram and need a separation. What is important to consider is, due to the stop, for example, from the OCTA BDE in 2004, and also a reduction of the use in production in the 1990s. For example, Japan has stopped the use of OCTA BDE already in 1995, I think. So the level of OCTA BDE already decreased in Europe in 2006. So what you see here is CRT plastic, and the content of the PBDEs listed in 2009. And you see here this electronic waste plastic sampled in 2003 in Switzerland contained 4000 milligram per kilogram. And then a few years later, it was only, that was here sampled in 2009. This means 6 years later, it was only 1370 milligram per kilogram. Yeah. And the same happens with the DKBDE, but only later, because DKBDE has been used longer. But this is also what we need to consider. Yeah, but let's say the time difference of POPs in the electronic waste might be different if a developing country starts to do management of e-waste plastic. Because when you start, also the equipment from even from 1980s might still be there with the high PBDE use. Yeah, and therefore we have done a study in Nigeria, Syndiku PhD, and there we found that the levels in the CRTs, cathode ray tubes, televisions, and computers in Nigeria was higher compared to Europe. Yeah, and therefore when you look to the guidance documents, you see that the data and the PBDE impact factors are from 2010 Switzerland, yeah, and 2018-19 from France, yeah. So while for Europe, maybe these impact factors today, 2024, might be too high, maybe when you start now e-waste management in Nigeria, they are still too low. Yeah, so therefore we think that the impact factor we chose at the moment are quite reasonable for low and middle income countries. Then for the management of e-waste plastic, certain limits were set, which decide about the recyclability of certain plastic fractions. So here we have in the European ROS directive, the limit for PBDEs of 1000 milligram per kilogram. The Basel Convention set provisional low POP limits for the sum of PBDEs, either what I said, 50 milligram, 500 or 1000 milligram, which then a national government can consider and put into national regulations, yeah, like the EU is doing. Yeah, at the moment, EU has set their regulatory limit to 500 milligram per kilogram, but in this new directive, POP directive, there is then the option on automatic reduction to 350 milligram per kilogram PBDE after 3 years of entry into force, and another automatic reduction to 200 milligram per kilogram 5 years after the entry into force. Yeah, so you see here, when you have good data, you understand, okay, this we can reach when we do a good separation, and this we cannot reach even today with a separation. And what you see here, these are data from a study in Sweden. So they have analyzed different plastic categories in respect to PBDEs, and here the POP content. And this is already plastic after separation. Yeah. So what has been found is, yes, all the plastic separated were below 200 milligram per kilograms of PBDEs. But at the same time, none of these plastic, even after separation, was below 50 milligram per kilogram. So if a 50 milligram per kilogram PBDE Basel Convention low POP content would be adopted, or unintentional trace contaminant, then recycling of e-waste plastic would not be feasible even for industrial countries. So this explained the discussion on the low POP content, and this is a heavy discussion now since several years in the Basel Convention open-ended working groups. And it also explained the stepwise reduction of the European Union from 500 to 350 to 200, and in future it can also go more down. But these data here from the International Pollutant Elimination Network on PBDEs and brominated dioxins in children toys, this explains also the position of the International POP Elimination Network and the African countries which are voting for 50 milligram PBDEs per kilogram. So what you see here is they analyzed different toys and screened it for bromine and analyzed then the PBDEs. And here, these car toys, the knife, the Rubik Cube, they had levels between 180 ppm to 350 ppm. Yeah, so this would be below the European 500 ppm, for example, and also below the Basel Convention 500 ppm. But at the same time, the levels of brominated dioxins were very high. This is 6,500 picogram TEQ per gram, 1,400 picogram TEQ per gram. You can compare to waste incineration fly ash. Waste incineration fly ash have normally mainly from chlorinated dioxins about 1,000 picogram TEQ. Yeah. So here you see that this car toy has the 6 times the dioxin amount in the plastics compared to a fly ash. Yeah. And then we are talking really about exposure if somebody is, for example, mouthing this toy. Yeah, so therefore it's also understandable why IPAN want to have a very low limit. Yeah, and then we have the other discussion: does the plastic go into electronic, or does the plastic go into a toy? So this kind of recycled plastic, even after separation, maybe should not go back to toys. Yeah, and one thing I want to highlight also in this slide is that the brominated dioxins are proposed as a POP by Switzerland and will be now evaluated in the POP reviewing committee, and maybe then in a few years also become POPs. So other POP plastic additives have lower relevance in e-waste plastic. So therefore I have emphasized here the PBDEs, including the impact factors compared to PBDEs. And also for the other POPs, there are less data for robust impact factors for individual POPs. Therefore, other inventory guidance documents at the moment do not have impact factor for other POPs, yeah, for the tier 1 or 2 estimate for quantification. But now for the sectoral guidance document, I tried that all POPs which are present in e-waste plastic are shortly introduced there, and where data were available, I have developed and proposed simple impact factor for other POPs, and you can have a look at it. It is recommended to use them for an initial assessment. So the data I used there was the most robust measurement of different POPs in V plastic, which has been conducted by the Swiss National Laboratory, published in 2017, but the e-waste plastic was from 2010. So therefore also I consider that this e-waste plastic is, let's say, quite relevant when we talk now about recycling of plastics in low and middle income countries. And I included a more recent monitoring of a range of new listed POPs, which has been conducted by the Norwegian EPA in electronics, but also in end-of-life vehicles. So impact factors are proposed based on these data sets, which can be considered a first reasonable order of magnitude estimate. Yeah, but you will see it is useful, especially then in comparison to the PBDEs. So when we look here now to hexabromocyclododecan, this was a major flame retardant, but it has been only a minor flame retardant in electronic equipment. And it has been mainly used in high impact polystyrene HIPs for example, for casings in IT equipment and televisions. The use of HBCD in e-waste plastic was not exempted and has likely stopped in 2013. This means, yes, only the plastics until 2013 in electronics might be impacted. A robust V inventory here from Switzerland, they indicated that the average concentration of hexabromocyclododecan in V plastic was 42 milligram per kilogram, and this was around 4% of the average DKBDE content. Yeah, so you see the relevance of the PBDEs here in comparison to the hexabromocyclododecan. It's more than 20 times more used and present in the e-waste plastic. Yeah, so therefore hexabromocyclododecan is only a minor flame retardant in e-waste plastic. So therefore, also HBCD has an overall lower priority compared to the PBDEs, since HBCD has mainly been used in high-impact polystyrene. This polymer fraction means HIPS can be impacted by hexabromocyclododecan even at level that exceed the unintentional trace contaminant of 100 milligram of HBCD. Yeah, so that's a study from Sweden, and I recommend it's a good study because unfortunately there's only a very few studies, and both are from Sweden about recyclates and POPs in recyclates. So this is a study from Anderson from 2019, and they found in their more than 50 samples, and this is already after separation the recyclates. Yeah, this is not the raw e-waste plastic. So in 2 polystyrene samples, they found that they are above 100 milligram per kilogram and would not comply to the regulations we have in Europe. So samples in total, when you look to the bromine content after separation, yeah, you see they are all below 1,200 milligram per kilogram. Yeah, the raw e-waste plastic can have also 3,000 or 4,000 milligram per kilogram of bromine. Yeah, but you see what is interesting, that the separation of brominated flame retardant containing plastic by the separation technology only removed the major share of the brominated flame retardants. Yeah, still, let's say 10–20%, depending on the quality of separation, is still there also after separation. So, and also what you see here, when you compare the gray color and the red color are the sum of regulated brominated flame retardants. This means PBDEs and HBCD. And the gray color is the total bromine. So what you see here in this fraction is fractions that the POP are only a small part of the total brominated flame retardants. Yeah, only here, for example, they make up to nearly 50% of the total bromine. Yeah, but there are other plastics, like here, for example, where we have 800 milligram of plastic, but we do not find the PBDs and the HBCD, but probably the detection limit is also here around 10–20 milligram per kilogram. Yeah, so therefore only a share is, even of the brominated flame retardant plastic, is impacted by POPs, and POPs like PBDEs and HBCD. I told you about HBCD. It was specifically used in HIPS, and also the PBDEs were mainly used in ABS and HIPS, and 1 or 2 more of these. So there are some plastics which are very low in flame retardants and low in PBDEs. So that's the same study. So the monitoring of this study in more than 50 recyclates found that all of the recyclates were below 1,000 milligram per kilogram of PBDEs. Yeah, and also none of the plastic were above 300 milligram per kilogram of PBDEs. But we had these 2 samples which were above the HBCD concentration, and this study also analyzed short chain and medium chain chlorinated paraffins in these samples. And they did not find short chain and medium chain paraffin in any of these e-waste plastic. So you see here for the normal e-waste plastic, ABS, polypropylene, polyethylene, HIPS, short chain and medium chain chlorinated paraffins are not relevant. But they have some relevance, and I show you the data here, what we have about short chain and medium chain chlorinated paraffins, which are still produced in high volumes and especially used in PVC, polyvinyl chloride, in rubber, and in polyurethane foam. Yeah, this means they are not real use in ABS, polyethylene, and polypropylene. Yeah, so that's major use. So when we look here to these major polymers, we see that PVC is used, of course, in cables in electronics. and other PVC components possibly. So a first monitoring of plastic shredder from V reported SCCP levels below 1 milligram per kilogram to 140 milligram per kilogram. And the medium chain chlorinated paraffin levels were between 16 milligram per kilogram and 1,700 milligram per kilogram. So based on these initial data, we have suggested a preliminary impact factor of 25 milligram for short chain chlorinated paraffins in e-waste plastic and 100 milligram per kilogram of medium chain chlorinated paraffins in e-waste plastic. Yeah, so that's for the average, the proposal for the average. Yeah, for sure, these levels will be higher in the PVC cables. Yeah, so if you only will analyze PVC cables, I can promise you that the levels you will find is higher than these proposed for the average. Yeah, so therefore, the chlorinated paraffins overall are not relevant for electronics and electronic waste, possibly for the cables. Also, when we look to Decloran Plus, it's another flame retardant, has been listed in the Stockholm Convention in 2023 with exemption for production and use. The production of Decloran Plus has been stopped. As we know, so China was the last producer and has stopped in 2023, and therefore probably there is likely no current new use of Decloran Plus. So Decloran Plus has been exempted for a range of uses, including aerospace, space, defense applications, medical imaging, and then also replacement parts, including here for electronics. There are also two data sets for Decloran Plus in e-waste. So here, the Swiss inventory sampled in 2010, they found a concentration, average concentration of 110 milligram per kilogram in e-waste plastic. And the more recent monitoring of Norway, but let's say that the Norwegian study was not as robust as the Swiss study in respect to sampling. We can discuss maybe at the end of the presentation. So they detected only in the rejected separated fraction, the Decloran Plus at 15 milligram per kilogram. And this 15 milligram per kilogram translate when you compare how much is separated and how much is recycled to roughly 5 milligram per kilogram in average in this Norwegian study. So therefore, based on these two studies, we have proposed a preliminary DP impact factor for V plastic of 40 milligram per kilogram. But yes, more data are needed. Yeah, but as a first rough estimate, it is good, and I would say that it's good by a factor of 3. Yeah. So then UV328 has been listed. This UV328 is a substituted phenolic benzotriazole UV stabilizer. It is the first non-halogenated chemicals listed in the Stockholm Convention in 2023. So it has a production exemption, so therefore it is still produced and the production is allowed if the party is registered. The use exemptions of UV328 include also electronics, electronic waste, transport sector, and here in electronics, liquid crystal displays, instruments for analysis, measurement, control, monitoring, testing, and so on, infrared radiator, thermometers, digital, you can check just in the listing for what is exempted. And at the same time, always for what it is exempted was also a use before. Yeah, so therefore, these exemptions are also a nice indication where you might find these related chemicals. Unfortunately, up to now, there is no measurement of e-waste plastic which could be used as a preliminary average level, no indication. And also, there is no data, for example, of the share of UV328 treated displays or other instruments. So here we strongly need more data on UV328 in electronics and electronic waste. What we have done on UV328 and plastic monitoring was last year, we had a larger sampling campaign of recyclates in Africa, in some African countries, in some countries in South America, and some countries in Asia. And from these countries in total, we sampled more than 300 recyclates, and 117 recyclates we analyzed here for UV328. And the levels of UV328 in the analyzed samples were generally low, and the majority of the samples were below the limit of quantification, which was for our study 0.1 milligram per kilogram, indicating that trace levels of these adsorbers are only present in a few samples. So in total, we have detected 20 samples above 0.1 milligram per kilogram, that's 17%. So 3 of these samples, this means 2.6%, were above 1 milligram per kilogram. These higher concentrations were found in a recyclate of a polyethylene, had 1.05 milligram per kilogram, then HIPS with 3.6 milligram per kilogram, and a PVC sample with 17.5 milligram per kilogram pellet samples. And the levels of the other 17 were somewhere between 0.1 and 1 milligram, and these were plastics included ABS, EPS, high-density polyethylene, another HIPS, another polyethylene, a PET, a polypropylene, and a PVC. So we need UV328 and other chemicals of concern of these benzotriazoles measure in more plastic fraction, specifically in major plastic fractions of the uses. In our study, we knew what were the materials which were processed, but we hardly had, for example, really clean recyclates from e-waste, or recyclates from end-of-life vehicle, because in Nigeria, for example, or in Ghana, you do not have that, or rarely you have that. Then there is a second study from the International Pollutant Elimination Network. They have analyzed high-density polyethylene pellets for UV stabilizers in 23 countries. So they found 17 of the 24 high-density polyethylene samples positive for UV328. So this is a much higher share than our study from the Global Monitoring Plan. But why? The reason is that they used much lower detection limits. So they went down 1 order of magnitude more in detection limit and quantification limit. And by this, then in many samples, they could find the UV328. But all of these samples were below 1 milligram per kilogram. So therefore, here, let's say our study and this study is in agreement. And this study also looked to other UV stabilizers. And here the concentration were up to 83 milligram per kilogram. And here, for example, UV326 and UV327, also benzotriazoles, were detected at higher levels. And some of these other UV stabilizers, benzotriazoles, are also substances of very high concern, which have been categorized by the European Chemical Agency as substances of very high concern, including UV320, 327, and 350. Then a few slides to PCBs and electronics. So the major use of PCB was in transformers and capacitors, but this is separately managed. But finally, capacitors are partly ending in V-recycling, and in developing countries, still some transformers might end in e-waste. So therefore, we find PCB contamination at e-waste plastic e-waste sites. PCBs have been used in small capacitors in different electrical and electronics, for example, ballasts in fluorescent lamps or in washing machines until 1980s. Recycling resulted in some PCB contamination and release when shredding. PCBs were also used as flame retardant in cables until the 1970s and might still impact some cable recycling. But you see, in 1970s, most of these cables already gone. Also, PCNs have been used in cables and capacitors, but at lower volumes and mainly from 1920s to 1960s. Therefore, has a low relevance for V-recycling and related inventory. and remaining PCBs and PCNs in cables would be addressed within an overall inventory and assessment of POPs in cables. So if you assess cables, you can analyze them not only for PBDEs, but also and SCCPs, MCCPs, but also for the other POPs. Yeah, and then we will understand probably that we will find quite low levels of PCBs. In the Swiss National Monitoring Study, they found in average a PCB concentration of 2 milligram per kilogram in electronic waste. And they stated that this mainly originated from these small capacitors, not from the cables. And this is just one slide how relevant these PCBs and electronic waste is. So we have IPAN, International POPs Elimination Network, and Pollutant Elimination Network have monitored eggs around pollution sites, and the highest contaminated eggs in the world was always found around e-waste recycling sites. And one example here for Kenya in the market, there was even not much open burning, but these eggs contained more than 500 picogram TEQ per gram fed, several hundred times above EU regulation, and this came purely from PCB. So you see that PCB has a relevance here also for your e-waste monitoring. So there are a range of other chemicals of concern in e-waste related to other multilateral environmental agreement, which can be addressed in a synergistic way for common inventories and implementation. This includes, for example, the F-gases, CFCs, HCFCs in refrigerators, freezers, air conditioners, which are partly ozone-depleting substances and greenhouse gases. We have, of course, the heavy metals, lead, cadmium. We have polyaromatic hydrocarbons. We have some other PFAS. There is some PFAS which have even been used as a flame retardant. We have the phthalates included, for example, also in PVC. We have halogenated phosphorus flame retardants, which are toxic, carcinogen partly. We have asbestos in some, for example, in electrical panels, wire insulation, cable wires, and of course we have the plastics. As a chemical of concern, and polymer is also a chemical. So therefore, this kind of assessment, when you do an e-waste inventory and pollutant inventory, you can include that. And actually the elements lead, mercury, arsenic, cadmium, antimony, and hexavalent chromium and beyond threshold quantities in electronic waste classifies electronic waste as hazardous waste. Yeah, so therefore, yes, the heavy metals are for sure very relevant. And also when you do this kind of crude recycling, the contamination by lead, for example, or cadmium of the areas are also of concern. And metals are a driver for the management and opportunity for financing of e-waste. So electronic waste contain about 50% of iron and steel, 13% of ferrous metals, of non-ferrous metals, like aluminium, copper, cobalt, nickel, also many precious metal which have value and are drivers for the management and recycling of e-waste. Metal should be considered in inventory activities for better management and recovery, and the value of metals can partly finance e-waste management. And if extended producer responsibility frames are set and implemented by this, I think we could globally manage e-waste more appropriately. Yeah, what happens at the moment is cherry picking. Some people take out the valuables, and finally the society remains with the non-valuables of the e-waste polluting the country. So for planning of e-waste management, a robust inventory of e-waste, including pollutants and resources, and POPs in plastic could be a global starting point for environmental sound management of e-waste plastic. And this is already 6% of global plastic in production, and in the stock, probably more than 6% of all plastic. One more slide to metals. In 2022, the overall global value of metals contained in e-waste was estimated to 91 billion, yeah, mainly from copper and gold and iron. But currently only around 28 billion worth metals are taken out of the e-waste. Yeah, so you see that there are 60 billion more which could be taken out of electronics if we would do a better recycling. So that's a major argument. Okay, so that was on electronics and electronic waste. And I don't know, Anastasia, if we have a question which we should address.
We do have a lot of questions, Roland.
Maybe let's say one or two, and then we see at the end how much time we have.
Okay, so we do have quite many questions from Georgia, Irakli, I believe. The POPs added by which year should be included in the inventory? And the second question, are there any questionnaires prepared for that that would help them in the process of the inventory of new POPs? And what kind of information should be requested from the customs for new POPs inventory?
Very wide. I mean, of course, we want to address all POPs. Yeah, I mean, I showed which ones are not relevant, and I will tell also one more POP which really does not have a relevance because of the early use. Otherwise, all POPs, even they, I mean, you cannot say we do not want to address PCB because it was only produced until 1980s. Yeah, so you see, especially here with the long service life, for example, of the transport sector and also of later the construction sector, that also the POPs which have been used in the 70s and 80s and 90s are still there. Yeah. So therefore, yes, all POPs should be addressed. About questionnaires, questionnaires are partly included in inventory guidance, in the specific inventory guidances. Yeah, so therefore you can go to the PBD inventory guidance, and there at the end of the guidance in the annex there are questionnaires also for the PFAS. Yeah, so this is about the questionnaires, and then you have, let's say, example questionnaires which you then can modify. About the customs, we have talked yesterday what is possible with customs and what is not possible with customs. One thing is, if you have the chemical in a product, you don't see it. It's not labeled. So therefore, customs hardly can, just by checking HS codes also, conclude on if a product or article contain POPs. Yeah. But for example, in Germany, our customs cooperate with laboratories. Yeah. And then when they have suspected something, for example, you get in a specific plastic which looks like recycled plastic something, you could analyze it. Yeah. So this is what I would recommend to the custom. There's also a small custom guidance on the website. Yeah. Okay.
Thank you very much, Roland. Do we have time for more questions, or do we address them a little bit later?
We do it at the end. Yeah, we do it at the end.
Okay.
Yeah.
Thank you.
Okay, because you saw that the one part of the answer was also for the next part. In the next part, we come now to the transport sector and POPs, overall inventory of POPs and other chemicals of concern in the transport sector. The transport sector is also a huge material and resource flow. Today, we have more than 1.4 billion vehicles globally, including 1.1 billion passenger cars. The 1.1 billion passenger cars contain approximately 200 million tons of plastic. With an average lifetime of approximately 15 years, every year approximately 14 million tons of plastic waste are generated from passenger cars alone, which need to be managed in an environmental sound manner. Yeah. So you see, we are always talking on e-waste plastic and e-waste management, but here, when you compare the total amount of plastic from end-of-life vehicles, they are probably higher than the plastics from electronics. The valuable metals, including ferrous and non-ferrous metals, including precious metals, recovered to a large extent by formal and informal recycling. On the other hand, plastic and synthetic textiles in end-of-life vehicles are often not recycled or recovered, but end as automotive shredder residues of approximately 300 kilograms for mid-sized cars. And in many countries, this goes to landfills. European Union, there is a regulation about high recycling and recovery rate. May be interesting to look at it and how Europe try to, let's say, also recycle this And even now there's a proposal that 25% of the plastic in new cars should come from recycled plastic. So considering the need to move to a more circular economy and a better recovery of resources and plastics, the other polymers from end-of-life vehicles need a better reuse and recycling. Yeah, I have highlighted the European Union approach. Within the management of end-of-life vehicle, the plastics, the POPs and other chemicals concerned need to be managed together. So especially when now increasing the recycling rate, it need to be considered that vehicles contain a range of hazardous chemicals such as POPs in some of the plastics, including synthetic textiles. Vehicles also contain other chemicals of concern which need to be managed. And the inventory of POPs and other chemicals of concern in the transport sector and in end-of-life vehicles is one basis for the environmental sound management of this waste and resource flow. Some impact factors for POPs have been developed for vehicles, so that's included also in the sectoral guidance. While for other categories, for example, trains, airplanes, and cruise ships, there are actually no data to develop an impact factor, but they contain for sure high level also of POPs, especially the airplanes. In the inventory assessment, the total amount of POPs and amount of POPs impacted plastic should be compiled. It is recommended that a rough overall estimate of plastic amount in end-of-life vehicles is established, considering the average plastic polymer content of this 200 kilogram, and therefore can be estimated if the numbers of cars are known. Also, the status of current waste management of the individual plastics and other waste fractions containing POPs should be described in the POP inventory here for the transport sector. This can contribute to an overall plastic inventory as a basis for environmental sound management of plastics, because we have here around 7% of all plastic uses in the transport sector, and considering also here the long service life, more than 7% of plastics are in the transport sector. An overall inventory of POPs in plastic in the transport sector would therefore estimate the total amount of plastic and other polymers, including textiles present in vehicles and generated by end-of-life vehicle management, considering the respective concentration of individual POPs in vehicles to estimate the total amount of individual POPs and possibly chemicals of concern in plastic and others, get information to the share of end-of-life vehicle polymers which are recycled, yeah, and the products which are manufactured, and then get information of the polymers which are not recycled and the current waste management and treatment management. And if possible, when it's recycled, then you can also do some measurements and see if the POP content is appropriate in the recycling. Also here for the transport sector, I have developed this kind of overview table with the different main POPs included in the transport sector, like the PBDs, HBCD, short chain, medium chain chlorinated paraffin, PFOS, PFOA, Decloran Plus, and UV328. And also I have tried to do a first prioritization recommendation, but also here, if you have comments, this can be modified. Then we come to the inventory, and also here for PBDEs, the most detailed is developed, again, because it is the most relevant POP in that sector due to the large and continuing use of DKBDE. Also for the transport sector, the PBDE is the most relevant. And for DKBDE, there is an exemption. And this exemption include a very long list of parts where the continuous use of DKBDE is allowed. And as I said before, it's very nice that we have this list, because by this list, you see what parts of the car are impacted or possibly impacted by PBDEs. Yeah, there's also one good study from Japan, from Kashiwara et al. From 2014, which has done more than 500 screenings of individual parts of the indoor of the cars for different plastics, and shown where the main PBDEs were in the cars in Japan. Then what I very much like, and which shows here the relevance also of the PBDEs in the transport sector, this is a dynamic material and substance flow analysis for PBDEs in the different sectors in the United States and Canada. And you see here, when first we look to the electronics, yeah, you see, yes, 1970s, it started with a peak use here until 2005. And then already the total amount of PBDEs in electronics decrease quite strongly, because this e-waste after a few years go into the waste. So therefore, already in 2020, in the United States and Canada, hardly DKBDE has been left in the electronics and in the e-waste. When you look to the transport sector, you see that the amount of total PBDE use was similar to electronics, but because of the longer service life of the PBDEs, also probably also in the United States, PBDEs might not have been used after 2010 and lowered already here in the early 2000s. Yeah, you see continuously the levels are stable. Yeah, because of the longer service life. Yeah, and therefore today in use, DKBDE in the transport sector in the use, and Canada is the largest stock here in this study considered compared to other uses. Yeah, also textiles has decreased much stronger. But in low and middle income countries, cars have significant longer service life, and therefore legacy POPs in these products stay longer in use. So here we have the service life here for industrial countries are 10 to 15 years. In Japan, often cars are exported when they are 7 years old, yeah, because at that time it's still a fresh car, so it's easier to sell. But when we have looked into Nigeria to the service life, and we have found that the service life of cars in Nigeria are more than 30 years. Yeah, so therefore these cars, and this is the case study which we have developed here for the sectoral guidance. That's the material and substance flow analysis of vehicles in Nigeria. And here we have done with Professor Babayemi the study on state-of-art material and substance flow analysis for electronics and also for the transport sector. And this is the overview of the total amount of DKBDE coming into Nigeria in the transport sector from 1980s to 2020. So in total, about 1,480 tons of DKBDE entered Nigeria in vehicles. And then when you look over these years, most of these vehicles which came in the last 40 years to Nigeria are still registered and in use. So therefore, we estimate that about 1,000 tons of DKBDE are still in use in vehicles, around 380 tons over the last 40 years with the vehicles have entered into end of life, and there we have made an estimate that most of it has gone into landfills, partly open burning, but interesting also a part of it has gone into spare parts, yeah, which are then reused in new vehicles, yeah. And this is the beauty about material and substance flow analysis. You really get a good overview on the flows and where the POPs are still. So this is the same material substance flow analysis from Nigeria. So what you see here, 1980s, it started to get vehicles containing PBDEs into Nigeria. And what you see here is the amount of DKBDE in end-of-life vehicles. Yeah. So what you see here, we are now 2020. Yeah. It is estimated that in this year, we have around 35 tons of DKBDE coming out from this total 1,000 tons, which we have still in use. Yeah, but this amount is still increasing by around until 2030. Yeah, in 2030, we estimate 2029 that about 45 tons of DKBDE comes into end of life from cars in Nigeria. Yeah, and you see that this is a big difference to the material substance flow analysis which we have in industrial countries. For example, there's the same material substance flow analysis for Japan, and they estimate that basically in 2-3 years the PBDEs in Japan will be gone out of the vehicles. Yeah, but a big part is going to developing countries, and within these vehicles at the same time 3.7 million tons of plastic have been imported to Nigeria in these vehicles. And from these 2.7 million tons of plastics is still in current transport, while about 1 million tons entered end of life, yeah, between 1980s and 2020. So if you do this material substance flow analysis, you can also then put other materials, the same you could do for iron, for example, yeah. So this was calculated by the impact factor given by the inventory guidance, and that has been developed from studies in Japan. So here, from this material substance flow analysis from Japan, from Liu et al. 2019, they have estimated that about 62 gram PBDEs was the average impact for cars. And they have analyzed this from car shredder residues and average content of car shredder residues. And then you can do a recalculation from the amount of the shredder with the concentration of DKBDE. You can estimate how much grams of PBDE you have in average car. What is interesting is that here the cars produced before 1999, they had around 80 gram per car, while for cars produced after 2000 in the shredding, so they contain only here 24 gram. In other countries, here United States, only 10 gram. So you see that also for cars, what I showed you before for the electronics, that the DKBDEs in these products are decreasing. Also, this happened in for the transport sector. This means cars after 2000 in average are lower contaminated. And this we have considered then for the proposed impact factors in the guidance. You see here the proposal is that for vehicles to use 80 gram of DKBDE for cars before 2005, 20 gram for cars between 2005 to 2017. And after 2017, we consider that not relevant amounts of the PBDEs have been used, and cars 2018, 2020 to 2024, new cars do not really contain relevant amount of PBDEs. So this is the way also we calculated it for Nigeria, yeah. And also in Japan, they have developed for HBCD an impact factor. So this was minor use, and in total, the average concentration was around 3 gram of HBCD in vehicles. This means only about 5% of the PBDE amount. So you see also for the transport sector, HBCD also it's a big was a big flame retardant. It's not so relevant for the transport sector. Then for hexabromobiphenyl, this has been only produced from 1970 to 1976 and only with 5,600 tons. So therefore, it's not relevant, not for electronics. For vehicles, it might only be relevant for a few classic cars produced in the United States between 1970s and 1976. So some of these cars are still traded. Looking to SCCP, MCCPs, which are additives in PVC. Also here we have a few data here from the Norwegian study, but and from Japan. So here in Japan, the initial measurements of automotive shredder residue was SCCP between 2 and 8 milligram per kilogram. And the levels in Europe was 16 milligram per kilogram. So you see also very close by a factor of 2 or 3, indicating overall low levels corresponding to an average of around 2.4 gram SCCP per car. Also, the MCCPs listed, which will be listed in 2025, have been analyzed. So the levels here are considerably higher. So in Japan, it was between 54 to 260 milligrams per kilogram, and in the automotive shredder residue in Norway from European waste, it was between 130 to 210. Also here you see the data are quite robust, very comparable. Yeah. So therefore we have proposed here for SCCP 2.4 gram SCCP and 50 gram MCCP per car. Maybe because these are mainly cars from Europe and cars from Japan, we know that China and India has a larger production of fluorinated paraffins. So I would be very curious about shredder residues and plastic from China and India. Most probably they might have higher values than here, but there are up to now no data. Then we come to Decloran Plus. Also has an exemption for vehicles, but like I said, it is not produced anymore. There was an initial monitoring in the European automotive shredder, and they found levels of 12 milligram in one of the samples and most below 1 milligram per kilogram. So therefore, this indicates also quite low use of Decloran Plus, likely below 3 gram of Decloran Plus per vehicle. Also for this, it would be nice to have more monitoring. For PFAS, also in the Norwegian study, there were some measurements. So PFAS have been used in vehicles, in textiles, treatment of textiles, but also some PFOA is present in fluoropolymers. And the concentration there was relatively low. So you see 0.048 to 0.067 milligram per kilogram for PFOA. For PFOS even lower, and for PF hexes even more low. So here the impact factor which we derived was 15 milligram per car, milligram PFOA per car for PFOA, 3 milligram per car for PFOS, and 0.2 milligram per car for PF hexes. But the total amount, in my opinion, of these PFOS, PFOA, PF hex related compounds is likely considerably higher. Why? Because here with the shredder, there was only a simple extraction by methanol. And with the simple extraction by methanol, you don't extract the side chain fluoropolymers. And the side chain fluoropolymers are probably the most application for the textile. Yeah. So therefore, we need more data, and this analysis should include also the top assay or some methods which crack the fluorinated side chain fluoropolymers. Last chemical here, UV328, also used, heavily used in the transport sector for many plastics, especially outside, including bumpers, grills, and so on. There is also exemption for UV328. Unfortunately, we do not have real data, measurement data, but UV328 is still there. And what we need is now really monitoring to understand how relevant it is. PCBs are also relevant for end-of-life vehicles. They are even more relevant compared to electronic waste. So car shredder residues have been analyzed here, for example, in the US, between 2 milligram to 210 milligram, but that was in the 1990s, early 2000s. Also in Europe, 2010, between 1 and 63 milligram. So here they are mostly below Basel Convention limits, but it can contaminate areas where you manage end-of-life vehicles. Yeah, and that's a study here from Japanese research groups. They have looked in Vietnam to end-of-life vehicle and end-of-life electronic waste sites. And what you see here for the electronic waste sites, the PBDE contamination at the site is higher for e-waste and lower for end-of-life vehicles, but they are both higher than background. And for PCBs, the levels in the end-of-life vehicle recycling side is higher compared to the electronic waste side. So, and we know, yeah, that also the electronic waste side, you get contamination of PCB. So therefore, I would be quite interested for end-of-life vehicle sites in respect to exposure to people, but especially also to chicken eggs. And we have a range of other chemicals of concern in vehicles. This includes lead, mercury compounds. I learned, knew when I developed that guidance that before 2004, there were a range of mercury applications like anti-lock braking system and so on. And for cars before 2004, there seems to be quite relevant mercury in some of the cars. Then again, the F-gases, other PFASs, and other halogenated phosphorus flame retardants. For the organophosphorus flame retardants, I added 2 slides because I find them so important. Because when you analyze car shredder residues, you find quite high level of this carcinogenic phosphorus flame retardants. And by this, we can estimate that each car contains between 5 and 100 gram of this organous phosphorus flame retardants comparable to the PBDEs. Yeah, and what we see now with landfill studies in Africa, Brazil, and China, that these flame retardants we have high leachate in landfills, probably from such waste like end-of-life vehicles, but also electronics and waste from construction. And when we look again here to different sites for e-waste management, end-of-life vehicle management, we see that the PBDs, these are the blue ones, are relevant. The phosphorus flame retardants are high and relevant. Other non-brominated flame retardants, these are in gray. Yeah, they are also relevant. But for example, they have analyzed here in Canada, China, Vietnam, Thailand, e-waste sites and some end-of-life vehicle sites. The levels of dechlorant plus is very low. Yeah, this is the green one. Yeah, so this means the impact factor also, which we have developed, are reasonable when we compare them to the real data and the pollution data there. So there are activities of improving end-of-life vehicle management. This is an example of from GIZ recycling of e-waste and end-of-life vehicle in Ghana, and there is also another study in Ivory Coast. So where we already have also CHEF projects. From which we do not really have data are all the trains, airplanes, and ships. Yeah, these vehicles have high use of flame retardants and are relevant, and therefore it would be great to have more data. End-of-life vehicle management, very relevant. Also the heavy metals, and like for e-waste, they are both. They are pollutants, and at the same time, they are drivers for recycling. In average, end-of-life vehicle has a value of $250 to $500 per vehicle. And therefore, if this partly could finance end-of-life vehicle management, and if we would put extended producer responsibility as a frame, we could manage these large material flow, including the POPs. And so here, because of the Stockholm Convention, countries have started in the frame of the Stockholm Convention first inventories to do inventories of the transport sector. Yeah, and detailed inventories and assessment of the transport sector often did not exist. Yeah, and these Stockholm Convention activities were the first activities in these countries to develop such inventories. So this can finally support the waste and resource management of this large waste and resource category, which contain, for example, 16% of all the steel in the world. So they are recycled, but often the plastic is not recycled. The total polymer content here is between 7 and 10% of all polymers. So therefore, if we do now a better inventory and a better management, this at the same time contribute here to a better plastic management globally, and can contribute also to the implementation of the upcoming plastic convention. We come to the last sector, buildings and construction. So here the building and construction sector is one of the most resource intensive, but also chemical intensive sector downstream of the chemical industry. Some of the chemicals in plastic and other materials in buildings and constructions are POPs. This include, again, hexabromocyclododecan, PBDs, short chain paraffins, PCBs, and PFOA, and other chemicals of concern. We will come to it. Construction and demolition waste is the largest waste stream in the world we have. More than 30% of all waste is construction and demolition waste. And considering the large waste volumes which need to be managed in the future, industrial countries move to a more circular economy of construction and demolition waste with controlled deconstruction, because it's very important to do a controlled deconstruction, because then we can better recover individual waste fractions and manage pollutants. And plastic materials from buildings, that's roughly between 1 and 3% of an average of buildings, need to be managed also in environmental sound management and be separated. And also there then POPs and plastic could be separated and recycled. But because the plastic has so long service life, there are at the moment not so many plastic recycling except of, yes, PVC from window frames and so on. But Germany, for example, in 2021 had a first study which did an assessment of the recycling potential of plastic in construction and demolition waste. Yeah, and I recommend, if you are interested, it can be downloaded there. The inventory of POP and other chemicals of concern in buildings and construction is one of the base for the environmental sound management. Governmental institution responsible for planning, guiding, and supervising construction and demolition waste should know about POPs and other chemicals of concern present to appropriately guide and supervise construction and demolition waste for optimum recovery of resources, including plastic. In the construction sector, POPs are mainly present also in plastics and polymers. And in the POP inventory assessment, at the same time, the amount of impacted plastic and related POP amount should be compiled, and the status of current waste management of individual plastic fractions containing POPs and other chemicals of concern should be described. This can contribute to an overall plastic inventory and an improved management of plastic. And you see here, plastic in construction is the second largest plastic use. And when you look to the stock, is today the largest stock of plastic. Yeah. So in overall, 20% of all plastic goes into buildings and construction. And then we have also here exposure risk. Yeah. This we know, for example, from the use of PCB in sealants, but also from chlorinated paraffin. I will show you some picture. So these plastics have a long service life and are today the largest stock of plastic. Here is an overview of the different type of plastics used here in buildings and construction. So we have here especially the PVC. And when we look to the use of short chain and medium chain chlorinated paraffin, the major use of short and medium chain chlorinated paraffin goes into PVC. Yeah. So we have also an overview table of the relevance of the different POPs in the construction sector. Again, the PBDs, HBCD, and short chain chlorinated paraffins. So they are very big and they are high. PCBs, it depends on the country. If a country like Germany has used PCB in buildings, it is very relevant, but not in developing countries. It might have not been used in the 1960s and 70s. I will come to that. So hexabromocyclododecan is here a big POPs used in construction. That 90% of it has been used in EPS and XPS. This means in total we have around 42 million tons of EPS, XPS insulation, which are largely still present in buildings and are one of the largest POP stockpiles. Yeah, so that's for construction. But it depends a bit, depending on the flammability standard. Not all countries have required the use of flame retardants in EPS and XPS. This is for Europe. This means when you do an inventory in your country, you first need to understand if flame retardants have been used and from what time on flame retardants have been used in insulation, that you can do an inventory. We have an inventory guidance for HBCD, and this is a table there. So we know what is the concentration of HBCD. For example, in EPS, it was between 0.5 and 0.7%. In XPS, between 0.8 and 3%. And if we then know the total amount of EPS and XPS installed at the time of use, you can calculate how much of EPS and XPS containing hexabromocyclododecan you have in your country. So this is the material and substance flow analysis from Beijing University. Li et al., I was also part of that. So they have done a nice material substance flow analysis of the use of HBCD in China going into construction. And then what you see here is the end of life management of EPS and XPS. And you see that here it is estimated that the largest waste of EPS and XPS entered the waste stream in 2050. Yeah, but we still in China, there will be EPS, XPS waste also in 2100. Yeah, so also you see here how useful these materials and substance flow analysis are. For PBDEs, when we look into the overall use, we see, yes, PBDEs have also been used in construction. For example, for DKBD, it's estimated that around 20% have been gone into construction with the long service life. Also today, probably construction might be the largest sector of PBDE today. There are also, let's say, data how much of PBDE are included if a polyurethane foam is used in insulation. Yeah, but unfortunately, we do not have really data on the share of treated materials. Yeah, so I don't know how much % of the polyurethane foam have been treated with PBDEs. We have at the moment a study at the Technical University in Vienna where they are doing some measurement. But at the moment, it is really a kind of a black box, the PBDEs, and a big knowledge gap. Yeah. So therefore, I recommend in some countries which capability to really do also studies on POPs in plastic in the construction sector. What we know is that for sure, short and medium chain chlorinated paraffins are most relevant. POP for the sector, about 60% of the paraffins in average have gone into PVC, and about 60% of all PVC is going to construction. And here it's especially the plasticized PVC, the soft PVC. Yeah, so it's not, let's say, the rigid PVC for the window frames. It is then rather, let's say, for flooring and for other materials where we have chlorinated paraffins in construction. One is PVC, the other is polyurethane foam. You see the concentration here, study from Europe, from polyurethane, chlorinated paraffins in polyurethane foam. And you see that some of the polyurethane foam spray contain up to 50% chlorinated paraffins by mass, up to 50%. Yeah. So in Europe, it was only medium chain chlorinated paraffin. The same study has also been done in China. And in China, it was a mixture between short chain and medium chain chlorinated paraffin in polyurethane foam. Yeah. So you see, yes, they are very big in construction. And we see this also from the data. These are data from house dust from Australia, Japan, Colombia, and Thailand. So you see here the medium chain in yellow. These are the highest concentration. This is concentration in, these are 100 ppm here. These are 1000 ppm. Yeah. So you see here in Thailand, the dust contain medium chain chlorinated paraffins in the hundreds of ppm. Yeah. In other, like for example, Japan, the levels are lower because Japan controlled, it seems to control or have controlled the use of chlorinated paraffins in construction. Yeah. But when we look the same here for Africa, that's South Africa. In South Africa, in average, the dust in houses had 130 to 230 milligram of dust of chlorinated paraffins in dust. Yeah. Also, again, mainly medium chain chlorinated paraffins, but also 23% of short chain chlorinated paraffins. So these most probably come from the PVC and polyurethane foam and rubber in the houses. Yeah. And also, when you look to the human milk study, Africa has the highest, one of the highest levels of short and medium chain chlorinated paraffins. Yeah. Also, dust levels in Beijing, China were high. Yeah. So therefore, that's quite relevant. We know how relevant the use and exposure was from PCBs. So here we know PCBs have been heavily used, Canada, Germany, Denmark, and so on, especially in sealants. But we don't know how the use was in sealants in developing countries. I've done with Lebanon an initial study a few years ago, and there we found that the sealants did not use PCBs because the PCB sealants were very expensive. So if developing countries are lucky, then they do not have really PCBs in sealants. Then PCBs have been substituted in the 70s by short chain and medium chain chlorinated paraffins, and that's just a data set from Switzerland. They have analyzed sealants from buildings from 1950s to 1970s, and they found that 30% of the sealants from 1950s to 70s contain PCBs at high levels, and 50% of all houses built between 50s and 75. And they found in the study that about a third of the chlorine-containing sealants contained chlorinated paraffins. Yeah, so that was a study from 2005. and this will be similar in other countries. Yeah, United States also had assessment for PCBs. They did estimated that the buildings with caulk and sealants constructed between 50s to 70s contained up to 50% of the buildings contained PCBs. Two examples of PCB paints which were relevant. You see here a bridge in Norway. This bridge contained nearly more than 1.6 tons of PCBs and paints. It was blasted and in the 1980s, and all the PCBs have been released into the environment. Similar in 2015, a bridge in Czech Republic. Also this bridge, just the amount of PCBs which have been ended from the bridge into the Elbe River was 500 kilogram PCBs. So you see that also this open application in construction of PCBs, also in paints, can be relevant. There are other POPs which lower relevance here in construction. I have listed them. You can have a look. What is maybe relevant are still the pentachlorophenol in wood, and also for pesticides. I just show you the example for Germany. In Germany, we had a big use of pentachlorophenol, but also other pesticides in wood in construction. And still, when we did the testing in 1998, 60% of the wood was contaminated. 2 years later, 50% of 1,500 wood samples contained these wood preservatives. Yeah, so you see, especially waste wood need a good management in the countries, and you need to understand from construction how much of pesticides and including PCP is in wood, and PCP is still exempted. In Germany, we therefore have a waste wood regulation where we really have a clear legislation what happens with wood coming out of construction which is impacted. And we have other chemicals of concern in construction. Big one here is asbestos. Then we have polyaromatic hydrocarbons in different uses, like also for wood treatment, for example, or tar roofing. We have again the F-gases here in insulation foams, for example. We have again halogenated organophosphorus flame retardants. We have also metal compounds like lead. Lead is very big. Lead in paints, very relevant for construction sector and management. We have tributyl tin compounds. And for the construction sector, I have included manufactured nanomaterials, because yes, manufactured nanomaterials are also SciChem issues of concern. And yes, I wanted to make a good link between our sectoral guidance and SciChem issues of concern. And for construction materials, it's maybe interesting. There are some national guidances published on the management of chemicals of concern in buildings, including POPs. Yeah, so this one is here from Germany. It's a very nice one, which gives a guidance how to demolish buildings and how before to assess buildings for the different pollutants before you start to demolish it. There is also a guidance documents from the EU on audits for demolition waste. And I think I would recommend each country to develop such a guidance. Yeah, so that will be useful for your management of buildings and and construction and demolition waste. And you can find them from Germany. Unfortunately, it's in German, but today with the translator, it's quickly translated. Also, Germany has technical rules for hazardous substances that require protective measures for demolition of buildings here, including asbestos and, for example, lead or PCBs, which is also relevant, and I wanted to mention it. So therefore, inventory and management of POPs in major affected sectors, and all the 3 sectors I mentioned, can improve the management of these large plastic use sectors. It can also result in depollution of these sectors. So we have experience now with the global phase-out of some of the POPs. Stockholm Convention parties started inventories and management of POP and plastic in these major use sectors. Now, with the addition of more plastic additives in these sectors like Decloran Plus, UV 328, and 2025, a very big POP, medium chain chlorinated paraffins, which very big use will come. This will further extend, and this can become an excellent synergy with the upcoming plastic treaty. So thank you for your attention, and sorry for the much text, but we have at least a few minutes left for discussion.
Thank you very much, Roland. That was indeed very extensive. I think we do have a lot of questions from different countries, but let me quickly come up with a question from Katka. Roland, for the European countries from the Eastern Bloc, the cost prevented us to have contamination by PCB and SCCPs. We haven't found contamination from indoor environment. That's more a comment.
But I mean, in Czech Republic, the use of PCB, I mean, you have seen the bridge, yeah? So, I mean, if I would be Retsitox, I would have analyzed all bridges in Czech Republic which are out of metal. And I know that also in Czech Republic, you had use of PCBs in farms, yeah? Also in Germany, we had the use of PCBs as in paints in farms. And I know that this is also in the Czech Republic. Yeah, so I think this would be a very interesting starting point. You have seen that bridge. So there are certainly other bridges. I know that there was also one big tower, a metal tower in the center of one city. And also this tower has been sandblasted and the whole city has been contaminated with PCB. I don't know, Katka, if you know this example. I think another friend of mine knows it. I can link it, so he could tell you which city. Yeah, so therefore, I mean, also for Czech Republic and maybe some Eastern country, at least the use in the paints has been relevant, but maybe not for indoor. Yeah, so the paints indoor might not need to be PCB paints. So maybe they have been done mainly for coatings for the metals, like for the bridges or towers. Yeah.
Roland, we have Katka here.
Yes, Roland, I can just confirm that yes, you are absolutely right. There was a use in cow yards, so in the farms, and yes, this is also the source of quite high exposure in to humans through the, of course, ingestions and through the milk. And then, of course, in the milk survey, that our levels are quite high as well. But I do confirm it is only not in indoor applications, but outdoors.
Oh, yeah.
So it's bridges and fences, and in very often military yards, as far as we know. So there's lower, of course, exposure risk for people, but for the environment, the risks remains there. Thank you.
Yeah. Yes, thank you.
Thank you very much, Katka. It was really nice to see you. Roland, we do have one more question about the German guidance for demolishing the buildings. If there is an English version, I remember you said that it's only
no, it's only German. Yeah.
Okay.
But I think it would be really nice, let's say, in the frame of the Stockholm Convention or Chemical Convention, or to develop such a guidance for the construction sector that will be really useful in future. Yeah.
Thank you, Roland. One more question. I think it's from Ethiopian team, and there were a couple of questions from Ethiopian team. Quite generic, but if you could just touch base on this. A lot of EEs have imported to developing countries from developed countries, and this could be dangerous to developing countries to manage the POPs. So what is the relationship between the receiver and importer countries to manage POPs containing EE? What changes are made now, a time by the EE manufacturer countries to reduce the amount of POPs in electronic appliances? And what do you think the monitoring of these EE imported and produced countries at global level? Are there countries that have good experience in reducing the POPs when producing EE using other alternatives? A very long question, but there were a couple of similar
one thing
ones.
is what I said for EEE also. At the moment, we still have exempted the DKBDE. China has stopped the DKBDE production. India might have DKBDE production, but in the first, they are doing at the moment an assessment for their NIP update. Yeah, so therefore, at the moment, I do not see, except of maybe this UV328 and the paraffins in the cables, that POPs are heavily used in electronics. But of course, now we have the second-hand electronics, and this second-hand electronics might come into your countries. So there, this you need to manage with the electronics. You know, there is a Basel guidance what is used and what is waste. Yeah, so waste easily you can reject. On the second hand, you can decide. And then the next you can decide at the custom level, and there is a guidance from the Basel Convention how to check if something is waste and if something is secondhand, and then to decide if you let it in or if you send it back. There was a project in Nigeria, at least, where they checked at the port. There are reports how to check containers in ports, let's say, to minimize these kind of e-waste imports to developing countries. And I know when a country sent back a ship with e-waste, this make noise, and then the import will decrease. But at the same time, you have your own electronics. It's not only e-waste which is imported. So overall, the own electronics which you are buying, also new, is today and in the last 10 years more than the e-waste you get. Yeah. So therefore, yes, and this you buy also voluntarily. And then it comes to the question of extended producer responsibility, where I said this is a key for all these three sectors. And for e-waste, there are examples of extended producer responsibility in Europe. For example, the whole e-waste management is made by extended producer responsibility, mean that the cost of waste management need to be included already in the sales of the product. And then you need to gather this money somehow, and with this money, then you do the end of life management. Yeah, so there are Ghana, Nigeria, they have it in legislation, but I know that it is challenging to put up finally the system. I know that also original equipment manufacturer, they are willing to do it, but of course it needs to have the right frame that you can do this extended producer responsibility. So my recommendation to Ethiopia is to look to Ghana and maybe to Nigeria, what they are doing with the extended producer responsibility in respect to legislation, and then also in respect to implementation. But I know that there are challenges.
Thank you very much, Roland. We do have still a lot of questions, but I'm afraid we are out of time at the moment. So,
but no, I mean, maybe we can do 3 more, huh? And then, I mean, people can leave which want to leave. Yeah,
okay.
Maybe we do 3 more questions, huh?
Okay, if we do not have possibilities to measure UV328 in cars in transport, do you think that is a value anyway to include it in the transport inventory?
I mean, I want to encourage that now some countries are doing monitoring to understand. Yeah, so UV stabilizers are heavily used. For developing countries, you know, you see with the guidances, we don't recommend that developing countries start to do tier 3 inventories. Yeah. And let's say also the UV 328 is relatively heavy. So let first Europe and Japan and maybe China do some monitoring and understand the issue. And then we will put together this information for the countries. Yeah. And then we see if actions are needed or not. Yeah, this would be my recommendation for the UV328. Yeah, but there will be sure now more monitoring and assessment. Yeah.
Thank you, Roland. And one last question. Is there any way for the consumer to know whether the EE they purchase contains POPs or not? And also the second one is also associated with EE. How are risks associated with the POPs in EE addressed, assessed, and managed throughout the life cycle of these products, from production to disposal?
Yeah, I mean, normally, let's say in industrial countries, you really have, when you have the application of a chemical in a product, you do this kind of exposure assessment. Yeah, but often the end of life is not really included. And if it's included, then it's included in the way that it's BAT-BEP in Europe. Yeah. So, and then you have good separation, and you destroy what is bad and you recycle what is good. But the world is different, of course, when we come to low and middle income countries. like I showed, often the e-waste recycling is not appropriately managed in the way which is considered in the regulation. So here we always have a problem. I mean, what we can say, for example, with DKBDE, that DKBDE is not really evaporating from electronics, yeah, in the normal use. Yeah, we know that when you have dust and dust on the electronics, then finally the DKBDE can go into the dust. But let's say this exposure is relatively small. When we come to the phosphorus flame retardants, and this is the reason why I included them here for cars and also for electronics, they are more volatile. Yeah, especially which I showed you, these chlorinated ones. Yeah, they are volatile, and we have sometimes 10 times, 100 times higher concentration of these phosphorus flame retardants indoor, yeah, and also in vehicles. There is a very recent study from 2024 in the United States, which have shown high levels of these phosphorus flame retardants in cars indoor, and also differences between summer and winter, where you really see, yes, with some of these chemicals, you really can get exposure, and the same is from electronics. Chlorinated paraffins, like I said, from electronics, you have in the cables. When you get these very cheap headphones in the airplane, for example, they sometimes contain chlorinated paraffins. They have a special smell. Yeah, I would say 20-30% of these cheap earplugs. Yeah, and then you really smell it. Yeah, and then when you smell it, you see it comes out. You have some exposure. Yeah, and also with all these, these chemicals which are lipophilic. Yeah, like chlorinated paraffins or PBDEs, you also get, or HBCD, you get a direct exposure via the skin. Yeah, there is studies from Herod et al. From textiles, direct exposure, but also from electronics. So if you really would then touch your earphones, so you would get a few microgram of chlorinated paraffins on your skin, and this is then adsorbed. Yeah, so this is the way of exposure. Yeah, when we have today, many of the brominated flame retardants are let's say polymers. Yeah, so these polymeric flame retardants, they do not have exposure. Yeah, so they do not leach from the plastics. So that's one solution. But we still have the problem in the end of life at the moment. We do not know if this is a PBDE or if this is another flame retardant. I have shown you today most of the brominated flame retardants are non-POPs, but because you cannot measure each part today, the brominated plastic is unfortunately not recyclable. Yeah.
Thank you very much, Roland. And I think we are 7 minutes behind the time, so it would be really great as to wrap up. And I would like to extend our gratitude first of all to you, Roland. Million thanks for this insightful session. And I think most of the people were listening to your presentation up until the end. That's really great. Thank you also for your efforts to update the sectoral guidance. We really very much appreciate it. And I believe all of us learned a lot again from this session, same as we did on Tuesday. Special thanks to all our project countries who attended today, despite the time. And for some countries, it was too early. For some, it was too late. Thank you very much for your time. Special thanks to my colleague Sumit for technical facilitation. Many thanks to our regional executing agencies for promoting this event, and deep gratitude to our interpreters. It's been really hard to handle this session. Thank you, Janika, Jolene, Eva, Maria, Carissa, Tatiana, Ilona. This is a really, really great work. Recordings of this event in French, in English, in Spanish, and in Russian, and the presentation materials, including the guidance, will be available on GGKP platform, and we will also share all the recordings and files with you by email soon after this event. And we are looking forward to seeing you again for online outreach consultations in the middle of August. Thank you very much, and have a great day, evening.
Anastasia, yeah,
Sure.
will we answer the other questions?
Yes. We will address them later. There are a couple of
Yeah,
left.
so therefore, the questions which have not been addressed, will be addressed later. So today I answered the question from 2 days before. So they will forward questions and I will try to address them. And then you will get the answers sent back. Yeah.
Thank you so much, Roland. And thank you very much, everyone. Goodbye.
Yeah, bye. No.